welcome back, and we are fresh back from the DFW Retro Computing Meetup, where we debuted the Mini Centurion for the first time, and probably the last time. And that sounds ominous and depressing, but it's not. Let me explain. However, first things first, the DFW Retro Computing Meetup was fantastic. I had an absolute blast. There was a ton of brilliant people that showed up and even more amazing machines. It was so much fun. I had a wonderful time. And I think the Mini Centurion was a hit. People seemed to really enjoy it, and they loved looking at it, looking at the cards, and well, they seemed to enjoy it right up until they tried to use it. It's just too slow. I mean, we saw how slow it was in the previous episode. It takes 4 minutes to boot into the operating system. But if it was just a slow boot time, that would be one thing. But actually using it is also painfully slow, and that's because of the way that the operating system is designed. For example, if I type .sta, that's a status. It's going to tell me the version of the OS, the amount of RAM that we have, the partitions, and all of that stuff. But that .sta is a JCL command, and that's not stored in memory. It's actually stored on the disk. So when I type .sta in, the floppy has to seek back to the Whipple, then seek to the directory listing, and then go find where .sta is stored on the disk, then load that into memory, then execute it, then erase that from memory, go back to the Whipple, hit up the directory listing again, find the parser, load that back in. It's just a nightmare. The floppy is constantly seeking back and forth. And well, if we compare that to something like, say, the Hawk drive, which has kind of become the standard for speed on the Centurion for us, well, it's the Hawk drive seeks almost instantaneously, and the floppy seeks not only a whole lot slower, but also 3 times slower than it's supposed to be seeking, because this is a CDC 9400, and we had to slow down the microcode on the FFC to match this drive, because the FFC was designed for like a 9404 or 9406. So it's slow. It's painfully slow. So we need to build something that's faster. And again, there's a bit of a deadline on this because, well, I originally built this for the DFW Retro Computing Meetup, but also for VCF East, which is coming up rapidly in New Jersey. VCF East is like the biggest retro computing meetup on the planet almost. That might be that might be over-exaggerating a bit. It's the biggest one in the US at the very least. So I want to take something Centurion to that event. And this was my initial idea, but man, it's just so slow. I can't demonstrate this there. That's where the best of the best is supposed to be. So we need to build this with a Hawk drive in it and take that to VCF East, which means I need to repair this Hawk drive and I need to build a completely new cabinet. Now, a single Hawk cabinet with the card cage underneath it was actually something that Centurion built. Their original CPU4 systems were exactly like that, and based around some measurements that I've been taking, that should fit in the back of our SUV. So this can work, but it all hinges on 1, getting a cabinet that's the right size, and 2, fixing a second Hawk drive, because I'm not going to take my only working Hawk drive with me. So we have a long road ahead of us, but the 12U server rack that I have ordered has arrived. So let's put it together, drop this Hawk drive into it, and get to work. This server rack is actually from StarTech, and I'm really impressed with the quality. It's very well made, and it went together really easily, and it's very sturdy. I'm not sponsored or anything, but I'm just happy with my purchase. It's a great server rack. Next, I want to get a few measurements so I know exactly where the Hawk will sit, so I can get the rails put in the correct place, and then I'll pull the parts Hawk drive out and use it for mock-up. But the bolt holes in the rails are just slightly too small for the bolts that go with this rack, so a quick file will open them up and allow me to then screw them right into place with no problems. Then we'll set the Hawk in and it hits. So off camera, I moved the rails down 1 notch, and now the Hawk clears that top piece. So we'll screw the front panel piece on and then slide it shut, and yeah, that's looking pretty good. Now that we've got our mock-up Hawk in here, we're running into some interesting problems. Originally, I had measured everything out for the Hawk rails to sit 1 notch higher, which would have brought the Hawk up a little higher. But when I did that, it didn't clear this top piece. So I moved it 1 notch down, but that introduces a new problem, and that is that this is the lower piece that covers up the card cage. And well, when I set it in place now, it's too tall. It's too tall by like ½ an inch, just hardly anything. So really the Hawk drive needs to be 1 notch higher because I don't want to slice this up to modify it to make it shorter, and I don't think I have enough time to build a new front panel that looks the correct color and everything like that. Man, I'm gonna pull out a tape measure and think about this a little more before I put the actual Hawk we're gonna work on in there, because if I gotta do any cutting or anything like that, I don't wanna do it with the one we're working on around. So I still got some thinking to do on this. All right, it's time to take the whole thing apart again and move the Hawk drive up 1 notch, back to the position it was in originally. And then I'll remove the top piece and take it over to the vise and do a bit of drilling on it. Actually, it's less drilling and more like assisted filing. The solution was actually a lot simpler than I was thinking. Instead of trying to build a whole new piece, it was easier to just hog out the mounting holes for this top piece here, and that allowed me to move the top piece up just enough for the drive to clear going underneath it. And then I just put some extra thick steel pieces here that are just bolted in place to make sure that that top piece doesn't push down as I'm going through and building up and working on the rest of this. So that seems like a pretty robust solution, and it was really easy to implement. I didn't have to cut or destroy anything catastrophically, at least. And well, it's still a tight fit, but check it out. The Hawk drive slides in perfectly, and here is our lower trim piece that's going to cover up the computer, and if we just set it right here, it clears perfectly. Now there is one small problem, but it's an easy one to fix. The mounting bolts for the casters here, 2 of them are in the way, and they actually push this up too far. So I either need to cut a tiny little notch in the bottom of this to clearance those, or most likely what I'll do is just remove those bolts and just have 3 bolts holding the front casters in instead of 4, which should be fine given that most of the time it's going to sit there with the floor levelers in place so that the casters aren't even really doing much. But there we go. The whole thing fits perfectly now, and that's, I think, gonna look amazing. We still have to build the upper panel, or the front panel that's gonna sit here, the side panels that are gonna go down the side that are made out of wood, and then we need to build the wood top piece, but this is pretty much exactly what the new CPU 4 style Centurion is gonna look like, and I think it's gonna be epic. But it's pointless if we can't get this Hawk drive to work. So we still got a ton of work to do on this one because the fixed platter on it is crashed. So well, let's start taking it apart and take a look at what we're up against. Now it's time to get the Hawk that we're actually going to use in place. And so I'm gonna visualize the lift because it's quite heavy, and then I'm gonna lift with my back, not my legs, and wait, I think that's backwards. No, it's too late. Okay, so we're just gonna put it right on the rails. Come on, just right on the rails. This is taking you forever, man. Come on. Oh, look, you knocked the air filter off. Just get it right into, all right, finally we got it. All right, so let's get that front panel off so we can get access to the disc itself. Then we'll undo the 3 screws holding this top cover on. Next, we'll just lift this cover right out of the way. And there is our crashed platter. To get it out, we just need to remove the 6 screws holding it in place, and then the platter and locking ring lift right on out. So ultimately, I'm gonna have to put a new fixed platter into this drive because this one is obviously crashed. It only crashed on one side though. This backside still looks all right, but it doesn't matter. A single head crash pretty much ruins that entire platter. It can never fly in a drive again. So initially I was hoping to use a Phoenix platter, and I have a Phoenix removable pack here. They're both 14-inch platters, and well, this Phoenix platter has already been crashed, so it actually is a good platter to maybe get some ideas for mocking up or something, because I can't hurt it any more than it already is hurt. And well, it's only been crashed on one side as well. The back side of it is totally fine. But I don't think that this is actually going to work. Yeah, the densities of them were slightly different, but they're both just rust painted on aluminum, and they both have the same size. They're both 14-inch platters with the same inner diameter here, but the Phoenix platter is a lot thicker. It measures out to 1.9 millimeters, whereas the Hawk platter measures out to 1.4 millimeters. And that's enough of a size difference that I think it's going to cause a real problem with getting the heads to fly. So I don't think we can use a Phoenix platter for our new fixed platter, which is unfortunate because I have like 16 of these, the majority of which are just boring data. But I only have 5 removable platters for the Hawk that I can essentially steal a platter from. 2 of those haven't been dumped yet because they require a different head alignment than our current working Hawk drive is set up to. So I really only have 3 removable platters to choose from. That's making it a little tough. So the current game plan is to use removable platter 1, which was primarily data, and we'll put it as the fixed platter in the new drive. But we have to do a lot of work on the new drive still to clean it up, as well as make sure that the head won't crash again, because a head that has crashed enough to cause a groove like this is going to cause a problem, because it can pick up microscopic bits of the platter that'll just cause it to crash again. So we still have some work ahead of us. If I remember right, the rubber bump stops on this one are completely toast, so let's get this permanent magnet off, and yep, yeah, those are pooched for sure. Fortunately, the remains of them can unscrew, and then a little bit of Gorilla Glue and a furniture rubber bump should do the trick. And I'll clean off the excess with a knife after it dries. And while it's drying, I want to clean the crashed head. So I'll put some paper between the heads so they don't actually hit each other, and I'll slide the carriage carefully forward, and oh, something's holding it up. Ah, it's a sensor, and to get to it, I need to get the power supply out of the way. So we'll just lift it out, and this is the forward end of travel sensor. And I had it out before, but when I put it back in, I didn't align it. So we'll just loosen it up and realign it so that now the carriage can actually slide all the way forwards, and I can get access to the heads. Then we'll remove the head locking bolts, and the heads sort of pivot off of the carriage, although it is awfully fiddly because there is quite a lot of spring pressure in these heads. Now the lower head, which didn't crash, actually looks pretty good. There's a few imperfections, but overall this looks pretty normal. However, the upper head, which did crash, definitely looks rough. There's a lot of scarring and material embedded into it, and so it definitely needs a clean. So I'm going to use a little trick Ken taught me to clean these. You take a piece of printer paper and lay it on a flat surface, then soak it in alcohol. Then you just run the head back and forth on the paper, and the weave of the paper acts like extremely fine sandpaper and cleans it right up. But the head shouldn't be forced down, just the actual weight of the head should be enough. So I gave both heads a clean, and the lower head looks totally perfect now. And the upper head cleaned up extremely well. If we compare it to before, where it looks really rough, after cleaning, man, you can see that that worked just absolutely brilliantly. So I popped the heads back onto the carriage, and now we want to get a new platter in place. So we're going to sacrifice one of the Hawk platters that we already dumped. This was the very first platter we dumped, and it's actually not even readable by the OS, so there's some kind of write error going on it already. Anyways, so once it's been freed from its plastic cage, Ken will then set it very gingerly into place. And then we'll drop the locking ring on top of it and finally cinch down all of the locking screws. Then we'll get that cover back in place, and getting this cover in place is really fiddly, so much so in fact that we just totally forgot where the camera was placed. But once the cover's in place, we'll just cinch it right on down with the 3 screws. All right, we've got the entire thing fully back together. You can hear it's probably crazy loud because I'm sitting right next to the cooling fan, but there is power into this thing. The cooling fan is running, and it's time to spin it up. The first time this thing's been spun up since the heads crashed way back when. Now, I'm not going to float the heads immediately. I actually have the heads totally unplugged, so they're just completely unpowered right now, and I've got the cotter pin in to keep them locked. So I'm just going to spin it up and let it spin for like 30 minutes or an hour or however long it's going to take to just purge everything. I want every speck of dust. I want everything out of there. So fortunately, if you unplug the heads, the hawk drive realizes that's what you're doing, and it'll let it just sit there and spin. So, well, here goes nothing. Let's spin it. I'm going to hit the start-stop button right here. I can hear it spinning up. I hear the belt on the bottom making a little bit of noise. It was doing that earlier, but it sounds like it's getting better. And it's just going to sit here and spin. So we'll just let it run. Whew, this is exciting. All right, let's plug the heads in, spin it up, and see if the heads load. And they didn't. They actually stopped short. I think this is due to crunchy bearings on the carriage there. So we spun it back up again, and Ken, the mad lad that he is, flew the heads by hand. And I don't hear anything funky at all, so I think the heads are flying properly, which is excellent news. But the bearings were definitely crunchy. So I took a little bit of sewing machine oil and worked it into the bearings. And so now let's spin the whole thing back up one more time and see if the hawk drive can load the heads on its own. And yep, there it goes. Excellent. The heads fly. It works. Victory. Almost. It didn't actually work very well initially. You can see we've got the mini Centurion out here, and I put the disc 1 and disc 2 cards in there and the diag card, and we plugged it into this so we could start running some tests to see how much of it was actually working, and not a whole lot was working. The seek test was a jittery nightmare. We weren't getting sector pulses for the fixed platter, which is totally unrelated to the platter itself. That's a separate sector wheel on the bottom. And it just, nothing seemed to be working quite right. It was indicating large scale failures of the hardware in the actual card cage back here. And that doesn't seem right. CDC built these things to be tough as nails. And so I pulled all the cards out and I said, you know what? I've been bit by dip switches before. So I took some contact cleaner, sprayed them into the dip switches, turned them back and forth a bunch of times, and everything smoothed right out. The seek test is now working perfectly. We have our sector pulses and index pulses that we're supposed to be getting. So I think it's time to start getting this drive to a point where it can hopefully boot. The removable platter right now is the removable platter that had the operating system on it. So we need to do a head alignment on it. And we don't really care about the head alignment on the fixed platter because, well, it never changes. So if we can get the removable platter reading and booted, we can then do a dump or a copy of the removable platter to the fixed platter, and then this drive will be in the exact same condition as the drive in the genuine system. We'll have two fully working Centurions. But in order to do that, we gotta align the heads. So it's time to pull the laptop out, fire up CCDP, and do a head alignment on this thing. I'll just fast forward through typing in the CCDP bootstrap code into TOS, and then once it's all in, we'll just go to 01E8 and execute, and then we get a little et symbol. We'll type in 32k.sys, and there we go. We're into CCDP, and that's epic every time I see it. Now it's time to start the head alignment program, and wait a minute, it's given me timeout errors. That's not right. Initially, I thought this was more dip switch problems, so I spent some time cleaning those, but that didn't help. In the end, it actually ended up being a bad analog board. I don't know, maybe a transistor on there was oscillating and having trouble keeping it on cylinder. But once the new board was in place, I fired up the head alignment program again, which is now working perfectly. But no matter what I do, I just can't get it to align. It's just constant X's for bad reads. All right, head alignment is not going great. There's a bunch of things that could be going wrong. The big thing that I think is what is holding us back is that there is an end of travel sensor. And so the way this thing works is that when you first do an RTZ, it sends the heads all the way out to the end of travel. And then it knows, okay, that's where the end is, and then it counts backwards from there. But if that end of travel sensor is adjusted in a slightly different position, it thinks the end of travel is maybe 2 tracks off or 1 track forward or backwards. So that end of travel position sensor has to be perfect. And I had removed that sensor at one point in time when I was pillaging parts off of this drive to get the other drive working. And so now that that sensor is back in place, it's totally maladjusted. And so I've been trying to slowly adjust it and then check the heads and then adjust it and check the heads. And I'm not getting there. And I don't know if I'm not getting there because I'm just not quite precise enough with that adjustment, or because we have something else fundamentally wrong with the drive. There's too many unknowns. So we need to eliminate a lot of those unknowns, and we can do that in one fell swoop because the Mini Centurion here has an operating system on the floppy. It's slow, but we do have the JCL commands, and the JCL command .format should format one of these platters. We can do a .format on the fixed platter, and if that passes, it'll let us know that 99.9% of the drive is functioning correctly. And so if it passes, then we just have to sit down and trial and error our way through that adjustment more and try to get it there. But there's only one way to know for certain that that is what is holding us up, and that's to run .format. So I'm gonna boot into the OS and we're gonna give that a shot. I'll skip past the 4-minute boot time of the floppy OS, but here we are in the operating system. I'll just type in .format1 to format the fixed platter. I'm just gonna make sure that everything looks copacetic, and here we go. Woof. All right, FLT1. That probably means fault 1, and it's just doing that repeatedly. That's not good at all. All right, so FLT1 or fault 1 that we're seeing in the operating system when we try to format the fixed platter is pretty indicative of a bad head, which is not great. And so I was trying to think of a decent way to test that. And the best way I could come up with was figuring out the pinout of the heads and measuring the resistance of the coils that are in the head. It should be pretty low resistance, but there should be something there. So I took the 2 heads that came out of the oldest, most original hawk that we got, the very first hawk that we got. There was 2 heads that were still somewhat okay. This is one of them, and I measured across all 3 coils in there, the 2 read-write coils and the erase coil. And the read-write coils measure out to about 1.7 ohms, and the erase coil measures out to 1 ohm, and they both measured identical to each other. So I think that's a pretty good methodology for at least doing an alive or dead test on the heads here. And it didn't seem to blow the heads out. I was a little worried about that because I know that multimeters tend to put a little bit of current through whatever it is that you're measuring, but I measured them multiple times and they came out the exact same every single time. So I pulled all 4 heads off of this drive and I measured the fixed platter upper head. That's the one that crashed that needed the most cleanup. And it measured out exactly the same, 1.7 ohms for both the read-write heads, 1 ohm for the erase head. So then I measured the fixed platter lower head. This one did not crash, but I did pull it out of the system to give me clean access to everything. And it measured with 2 open coils, and that's not good. That's pretty much a dead read-write head. We can't do anything with that. There's no way to bring that back. And so, man, I started thinking maybe, if we get really desperate, we can build this into a single platter hawk. So I can take the lower head from the removable platter and move it down to the fixed platter, and then at least we'll have a 5 megabyte drive. So I decided to measure the resistance of the removable platter heads, and both the upper and lower heads on the removable platter measure with 2 open coils. That's bananas. Neither of them had ever been crashed in their life. I didn't even remove them from the system. I never even touched those heads. I just assumed they were good. And so maybe they died before I got the drive? I don't know, but I've got, out of the 4 heads that I have in here, 3 of them are measuring with open coils, and the only one that measures good is the one that crashed. And well, I have 2 more heads that came out of that original system that both crashed so hard they left an inch-wide stripe of exposed metal, meaning that it just chewed off all of the ferrous material there. So I don't know if those can be brought back to life, but I'm certainly going to try and clean them up and smooth them out, because at this point in time, hawk heads are becoming kind of rare. And so I think that's going to be the next path that we run down, but I don't know. I'm going to sit and think on it for a little bit. I really wanted this video to end with me going, hooray, it works, but instead it's, hooray, it's all broken. That's how it goes sometimes working on these things. But, well, I'm gonna channel my inner John Connor. I can't let the machines win. We're not going to give up on this thing. We're going to fight it to the very bitter end. And hopefully in the next episode we can get some data onto this thing and back off of it again. So I want to thank you guys so much for watching, and I hope to see you in the next episode.